Welcome back. We've learned what a linked list is and we've visualized a linked list in a 2D array. Now we're going to write a program in Python to make and maintain a linked list. In this lesson, we'll start by thinking about the features of a linked list. We'll create a linked list in Python and then write code to print a single node from the list and to traverse the list, printing the values in all the nodes. Remember that a linked list is a data structure made of nodes. Each node has two items, an item of data and a number, which is a pointer to the next node. We can visualize it as a set of nodes joined by arrows. Of course, there aren't really arrows inside the computer and we won't use arrows in our programming. We can also visualize a linked list as a set of data values in a 2D array. When the computer works with a linked list, it has to remember two extra values: the position of the header, this is where the linked list starts, and a location of a free pointer. This is where we can store new items of data. Now, to help my students, I've created an example program, but if I show that on the screen, you can copy it easily enough if you want to follow along at home. My example program has created a linked list using a 2D array. Now, you might remember that the Python itself does actually use a linked list structure to maintain its data structures, which means that we don't really have to do all of this. Python will do it for us. We're just doing it today to learn a little bit more about how linked lists work. So I've made a pretend linked list by storing data values and pointers, and each value points to the next value in the list. I don't really need to do this. Python will do it all for me, but I'm doing it because I want to explore linked lists in my program. So if you copy a 2D array like this, and that will make a dummy linked list. The header is 0 because the first item in the list is position 0. And the free node, I'm pointing it to position 7 because item 7 in my list is empty, ready to take new data. So let's add a couple of lines to the program so that we will print the data from the first node in the list. The first pointer is header. So the first node in the list is mylist square brackets header, and the data value is position 0 within that sublist. So see if you can do that, and I'll show you the answer in a minute. So the first pointer is to the header of the list, and the first node is mylist square brackets pointer, and the data is value 0 within that node. So if we print the data, those three commands will take us to the header of the list, find the node at that position, take the data out of that node and print it. You can do this in fewer than 4 lines. So you could write it like this: mylist square brackets header square brackets 0. But as you know, I prefer to set things out on several lines because it makes it clearer and easier to read. Okay, so now we've created a short program that just prints out the first item in the list. Can we put this inside a loop so that we keep printing data and updating the pointer? until we reach a place where the pointer is none or null. At that point, we've reached the end of the list. So again, pause the video, see if you can change the lines that we've just written so that we're now traversing the list repeatedly until the pointer is none. Don't worry, I'm going to show you the answer in a second or two. So pause the video, have a go. What's the worst that can happen? So here's how we would do it. While the pointer doesn't equal none, so in other words, until we reach the end of the list, the node is mylist at the pointer, the data is the first value in the node, and the pointer is the second value in the node. We then repeat with the new pointer and repeat again, updating the pointer each time until the pointer has the value none, and that's when we know we've reached the end of the list. So that is a complete program there to traverse a linked list, printing out the data at each node. So if you haven't done so already, I strongly recommend that you write this program. You have to have the linked list already set up on your computer. So in this lesson, we've looked again at the features of a linked list, which is a group of nodes. We've created a linked list in Python out of sublists. We've added code to print a single node at the header of the list. And then we've put that code inside a while loop so that we can traverse the entire list. So I'm leaving you with the activity of writing a program in Python to traverse a linked list. There are a number of other operations in a linked list, such as append, insert and delete, and we'll look at those in the next presentation. So bye for now.